Okay, let me see quick time. So we're gonna talk about extreme value theorem today. Tomorrow we're gonna talk about mean value theorem and Rolle's value theorem. I know a few people will not be here tomorrow due to PSAT. Who was it? Oh, that sucks for you. I'm glad you too though, because you two can catch up pretty quickly. Um, but I feel bad for you. That sucks. If the things happen. I cannot see my iPad screen. Sorry. Nothing's working today. Everything against my way. God doesn't want me to exist. It's okay though. I'm gonna smile and hopefully it works. I cannot see my iPad still. Let me unplug. Back in. Ah, there it is. There you go. All right, yay. All right, so what is the extreme value theorem? Basically, the extreme value theorem, it's just basically says if f is continuous between the bracket a comma b, okay, a comma b, then f has both minimum and maximum. And that's it. Even though it's very intuitive, but you want to take exception. Why do they have a closed interval a and b? And why it has to be continuous, right? So imagine that we give you a counter example. Counter example. What now? Why is nothing work? They like to play with me. Counter example. Okay, counter example. So when you have, let's say a to b, I have a function is not continuous. Imagine I have a function is not continuous. And that's not continuous, right? There's a hole. Now, is a minimum? Is it a maximum? Why Armand says there's no maximum? Well, that, but why it doesn't have maximum? Let's just imagine there's a 3.5, right? This is an open circle. Yes. Go ahead. Well, it's not that. It's, you know, like maximum can be the closest is probably the open circle, right? And roughly we can estimate that's 3.5 if we go with the graph. But the problem is, how do we know it's 3.49 or 3.499 or 3.4999? So when a thing is not definable, math just they'll rather tell you there's no maximum because it's not able to define are they a maximum or a minimum. In this case, there is a minimum here. There's a this called absolute absolute minimum? There's a minimum because between that and to like 2, there's our is our like, you know, thing. So there's no maximum. So no maximum here. Now why it has to be endpoint also? This is another counter example. What if we have this? Right? This solid dot on the bottom. Do we have minimum? No, because we can't really define it's negative 0.9 or negative 0.99 or negative 0.999. We cannot define what the minimum is because of the open circle. So that's why it has to be continuous from one point to the other point. Imagine the example of extreme value theorem. I just pick one example here. I'm just going to draw a random graph. Like this. Is there a maximum? A and B is continuous, right? Now we gotta learn how to categorize this maximum minimum. How to categorize it. So some people says we're gonna show you a keyword. It's called relative. Relative maximum and relative minimum have a common characteristic. They have a changing of slope, changing from positive to negative or negative to positive. So in this case, there is a point right here, and there is a point right here, and there is a point right here. This is all relative. This is not only relative, this is relative max. This is relative min. This is a relative max. Now, relative, it has to go up and come back down, or go down, come back up. It has to have a changing of slope. Yes, Caden?
You just answered.
Okay. It has to changing of slope. And it go up and come back down. That's it. It turns out it's really easy to find those places. If I have a function look like this, how do I find it? How do I find them? How do I find a possible relative maximum minimum? Balin, what'd you say? When slope equals 0. By the way, Balin got 100 on related rate test. I never told anybody. Balin sometimes drive me crazy, but he asked me a lot of questions after school, but I guess it comes down, if he put his mind, he's very, very intelligent. Yes?
Why are there two relative maximums?
Because it has to go up and come back down. Long as you have go up and come back down, then that's the relative maximum.
And then if it goes down and comes back up, it's a minimum?
Yep.
Okay.
And also this particular point right here, we're going to call this as an endpoint minimum. Because not only they are endpoint, they are the lowest point in the graph. So we're going to give him a new name. The new name is also known, this one can be also categorized as absolute minimum. And this point here is actually absolute max. So absolute means the highest point in the interval or the lowest point in the interval. It doesn't matter, are they going up, back down, it could occur at an endpoint. So in this case, it occurred at this particular endpoint right here. Right, it occurred at this endpoint right here. It's the lowest point in the interval. So we call that endpoint minimum. At the same time, we call that endpoint, we call it absolute minimum. Absolute because lowest one. You cannot get any value lower than that. Does that make sense or no? Okay, so that just is some understanding. But yeah, how do you find the maximum minimum of a function or possible maximum minimum? You just have to take a derivative equal to 0. right? Derivative equal to 0, right? This is all the possible situation here. It's a horizontal tangent. Duh is where the horizontal line, the slope is. Now, you're gonna say, is all horizontal tangent means maximum and minimum? Can you think of an example that is f prime of x is equal to 0, but it's not maximum and minimum? Yes.
Say the graph for a solid piece of it just goes straight, where it comes from the bottom, goes straight, and then goes up.
Okay, what's the function that you can think of that like goes through like this?
Piecewise.
No. Almost like a parabola.
Exponential?
No, or almost not exponential. Sine doesn't do that, but I can understand why you say that. Who says cube? X cube, right? X cube graph goes like this, right? Like this. So this, it has a horizontal tangent, but it doesn't mean they are maximum minimum. So sometimes you just only can find a possible maximum minimum by setting derivative equal to 0. It doesn't mean they are always maximum minimum. So we're going to talk about that in a second. But here's the coming the statement. This statement from the book. And you got to pay attention to what the statement says. If f... Oh, no, sorry. Let's not talk about the statement first. Let's talk about something else. We're going to talk about critical number. Critical number, it just means f prime of x, f prime of c is equal to 0. Then c is equal to critical number. So just like you're finding horizontal tangent. If you find a horizontal tangent, that is a critical number. Yes.
Can there be multiple?
Yes, they can. In this case, they have 3. Yes. Yes. But you're gonna be like, hey, what's that difference between finding horizontal tangent? There was a plot twist because there was second condition for the critical number, which is nobody ever talked about and not mentioned a lot and not tested often, is when f prime of c is equal to undefined as well. So that's also a critical number. Now I'm going to color code for you the first situation. The first situation more likely to be like something like this. More likely like something like this, right? There's a C. That's a maximum. It could be a minimum. It could be a parabola facing the other way. Right? That's the first situation. That's when f prime c is equal to 0. There's a value of c there when you have a horizontal tangent. But you could also have the second case, which is I'm going to write in pink. It's undefined. I see here, this f prime of c is undefined. As no a i.e. is cusp. You can have something like cusp like this. Yep. F prime c is equal to undefined. You can have absolute value as well, by the way. Think about it. Absolute value is also f prime c is equal to undefined. Because the left side of the slope does not equal the right side of the slope. So that could be a critical number as well. So there are 2 conditions that qualify for being called critical number. The first condition is very much like horizontal tangent. Second condition is like any type of sharp turn. Got it? Now on the book, they also says there was a theorem. They say relative extrema only occur at critical number. So this theorem says relative extrema occur only at critical number. if f has relative max or min at x equal to c, then f prime of c must equal to 0. Now the problem in this statement is actually very interesting. A lot of people says, for example, all cat are animal. But can you say reverse? All animal are cat. Then that doesn't make sense. I don't know what's that logic part of it. You guys study speech. This should be one of the term, right? What is it called? I don't know. Debate, speech and debate. I don't know. It's something like that. I don't know. I never take.
I think it's called
Is it?
Just say logical.
Is it logical fallacy?
There's just probably a specific name.
There is a specific name for it. I don't know what is it, but
I'll look it up.
but it's just an example that you cannot say it reverse because reverse doesn't make sense. You can only say it one way. Now I don't know anything about debate, so that's what I'm asking Among or Gabby or things like that because you guys are expert at those. Or like says all square are rectangles, but not all rectangle are square, right? So those are things that you have to say. That's also in geometry too. I don't know if there's any term for it. I don't know. Yeah. Yes.
So the second example doesn't apply to that quote because it's not continuous.
It is continuous. This example is continuous, so there's a maximum there.
It's called a fallacy of definition.
A fallacy of definition. Oh, thank you, Corbin. See, if you're not asleep, you are so effective.
I use Google.
Use Google. At least I don't even know what to search, so you're better than me. Yes.
No minimum, or is there a minimum?
It doesn't have to. I can have a minimum like this. I mean, I can have a minimum like that.
What's only one of them?
Or you can be both. I just don't know what a function look like. I don't know how to name that function to have two cusps. I know how to name one cusp, but I don't know if I can make it two cusps. But it's possible. As long as you have two condition. I think you have two condition, then you should have two cusps. Yes. Sine inverse of sine. Or sine inverse of x. Actually, it's pretty cool though. It's not cusp. You know this is sine of x, right? And if I do a sine outside, and which is on one of the trick questions, like a lot of you guys says it would make sense. It looks like that. It looks like a sine function, but it's like straight line. But yeah, a lot of people don't know this stuff. Huh? For maximum, they all have the same value. Yeah. All right. So let's talk about how do you find extrema interval on a closed interval. Oh yeah, closed interval. First, let's find the critical number of f in A and B. Second, evaluate f at each critical number. Three, evaluate f at endpoints. Now, so depending on how many critical number you find, depending on how many, there's always 2 endpoints. So it's, 2 plus some type of critical number in this case. Evaluate it. What do you mean evaluate? Evaluate means plug in the original function into original, not a derivative. Plug in, see what the value is. Third, the last one is what AP rubric want to look for. The last one says compare each output on the table. Now this is a very, 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 very important table. What do I mean table? You compare each output on the table, and then you can decide absolute max and absolute min. So we're gonna show you how to do that. So this is in purple, most important stuff. Find the critical number, find the endpoint, plug in the endpoint, plug in the critical number, and then going from there. Decide absolute maximum and absolute minimum. So we're going to show you how to do this question. So we're going to start with the f of x equal to 3x to the 4th minus 4x to the 3rd. And between -1 and 2. So there must be an interval, right? So first of all, find the critical number first. I don't want you to go ahead, but find the critical number because I'll show you. Do you know how to find a critical number? It should take like 20 seconds to find a critical number. Power rule, yeah. And so they go to 0. This is 12x to the 3rd minus 12x squared. You can factor out what? Can you set each factor equal to 0? Of course. So what you're going to do is you're going to construct the table. And this table is very important for the rubric of the FRQ. You're going to be, I've never seen FRQ look like on AP exam. But I will tell you, this is the one thing they're looking for. They don't want you to write essays. For AP exam, they don't want you to write essays. They want you to be able to justify in the way they want you to justify. So I'm going to plug in x, and this is f of x. Which value do I do? Well, there's a -1, there's 2. There's endpoints first. So obviously those are important. But also all the critical number. In this case, it's going to be 0 and 1. And you're going to be like, hey, Mr. Ye, does that mean I need to plug in every single value? No. Again, owning, I'm going to say again, owning critical number and owning the endpoint. In this case, happen to be every integer between -1 to 2. But what if my endpoint's 8? If today my endpoint is, just says this is 8, then do I need to plug in every single value to 8? No. It's going to be -1, 0, 1, and 8. I don't need to plug in every single value between -1 to 8. But this time it's 2, so we're just going to stop by 2. Sometimes I can go all the way to 8, then you have to evaluate it. What happens if I plug in -1? You will get -7, right? What happens if you plug in 0? Oh, my bad. +7. I can't add. F of 0 is going to be 0. F of 1 is -1. F2 is 16. Then you say, oh, okay. Where's the absolute max? Depends on what the question is asking. This is absolute max. But if you ask where does absolute maximum occur, you're gonna say x equal to 2. At x equal to 2. Now, if I say absolute maximum value, what does value mean? Those in my class, we know value means YU. That means 16 is, if I ask you where does x occur, then you're gonna say 2. But if I ask you absolute maximum value is, you're gonna say 16. So value, same thing as YU. Is that okay? Eli, I have to say you had the best costume. Well, he's white too, so it kind of helps. Huh? Chase? Okay, so how about absolute minimum value? What's the absolute minimum value? -1, not 1. Where does that absolute minimum occur? Then you're gonna say at -1, or at 1. But value is gonna be -1. Does that make sense? So there's two different sort of questions that I can ask you. You have to figure out. Are we okay here?
Critical value is
1 and 0. Now this one's kind of tricky. I want you to find critical number first, but don't go further because most of you guys will probably find a critical number to be not correct. How do I find critical number here? Or numbers? How many critical number you find? Yes? Actually, there was 2. It's really hard to find a second one. Because that's gonna be 2. That's fairly easy. Minus 3 times 2/3 times x to the -1/3. Now, how do you find the second one? That doesn't make sense why Mr. Ye says there is a second critical number. Now, let's start writing in term of right way. So it's going to be 2 minus 2 over cube root of x. Is that okay? What I can do is combine fraction. So that's equal to 2 cube root of x minus 2 over cube root of x. Now this is f prime of x, right? Remember, there are 2 conditions to have critical number. First condition is if f prime of x equal to 0. Second condition, what if f prime of x is undefined? Which is in this case the denominator equal to 0. X equal to 0. In this case, 2 root 3 root x equal to 2. Divided by 2, x is equal to 1. So x equal to 0 and x equal to 1. because cube root of x is equal to 1, so you can cube both sides.
Why is C equal to
What?
why is equal to 1 then?
Because the 1 to the cube is 1. I 2 both sides divided by 2 on both sides. It's canceling. Yeah, so this part is just cancel out, so give me 1. Because the bottom also equal to 0. Bottom equal to 0, the function is undefined. Now this one's not often tested, but just so you know, you can have possible 2 situation. It also means critical number. Is sometimes it can be absolute value graph, right? You can say, oh, this part is f prime c is this is a critical number as well, if they ever ask that. So yeah. So now I'm gonna do a chart x and y. We already know it start at we start at -1 to 3. I forgot to write down the interval. So -1 and 3. But we also know there was a 0 and there was a 1. Do I need to do 2? 2 is not critical number. Why should I do it? I'm just gonna do 3 right here. I'm gonna say I don't need to do 2 because 2 is not part of it. Now what do I plug in? I plug in the original function. If I plug in the original function, I'm gonna get -5. I'm gonna get 0. I'm gonna get -1. And if I plug in 3, I'm gonna use calculator over this one, so end up to be -2.4. So this is absolute maximum value. And this is actually absolute min value. Oh no, sorry, this is the other one. This is the min. And this is the max. Thank you. So it's the other way around. I'm sorry. But you do those comparison because your highest point can only occur at maximum minimum. So that's why you compare with the critical number. It can happen at critical number. It doesn't have to be, but you have to compare with the endpoint to decide which one's higher, which one's lower. Yes, Brandon. Not right now. You just have to find me absolute. Later, I'm gonna teach you how to find relative maximum minimum. Right now, we just want to find the absolute maximum and absolute minimum. That means the highest point of the graph or the lowest point of the graph. Usually it's 1 point, but it can be multiple points. Like sine graph, it has multiple maximum, multiple minimum, infinite amount actually, because they fall in the same height. On the maximum, it just occur at different places. Yes, babe.
Finding the absolute maximum minimum values and that you really need to do the number, just plug in things.
You have to plug. Yeah, you have to find out where the critical number is and plug in the original function to compare. And that's it. It can be sine cos. How much time I have? Challenge accepted. Let me teach you one more problem. No, kidding. Jenny, I can teach you one. I can teach in 10 seconds. Except I only have 2 seconds, so I don't have enough time. No, bro, it's random. I don't think they